So hello student, welcome back to our video classes, and I am Anik with you, your chemistry teacher. I think you have gone through all the things we have read so far, isn't it? So right now we are on the L8, lecture number 8 of chemistry, language of chemistry, right? So this chapter is very much important. So actually what happened is in the last video we were just discussing about the different types of atomic structures, isn't it? So we were just discussing about how the atoms are being generated. But today we are going to discuss about the electronic configurations. And this electronic configuration has its own nature. There is a way through which we are going to find out about the electronic configuration. If you don't know the models like the Bose models, like the Rutherford model, those things, then I would strongly suggest you to go through the previous videos. After that, come back here. Otherwise, you would not be able to understand why the electronic configuration is going on like that. Okay, so I would strongly suggest you first go through the previous video. After that, come to this video. And I think you're solving questions every day, right? And if you have any doubts, you just post it in the forum, okay, and one teacher would get back to you within 5 to 6 hours. Fine. So I think you are understanding the topic so far. I have taught you about the atoms, how the atoms were getting generated, what are the theories behind it, and all the models, right? Now from there we are going to understand the electronic configuration, the valence electrons, the valencies, and the different types of FAQs. So here, electronic configuration. This is the first thing we are going to start with. And from the name, I guess you can understand that electronic configuration. Electronic means it has something to do with the electrons, right? And configuration means the arrangement. Configuration means the arrangement. So the electrons in which they are being arranged, okay, in the space, that is called the electronic configuration, isn't it? So we are going to learn about the electronic configuration, like the array of the electrons, how they are in the atoms, in the shells. So that is the thing we are going to learn today. Okay, and as usual we are going to watch some cool videos, and we are going to go through some important things that right now that is there, not there in your normal textbooks, but definitely you would come across with those ideas if you just go through the FAQs. Okay, so let's start this video with this, and definitely we are going to start this video with a very impressive video in the YouTube about the valencies. So let's just see. It'll take a couple of minutes, maybe. So the context of the video is, they are trying to discuss about the valency only. Now we don't know about valency so far, but let's see what they are trying to say. So what are they trying to say? They have just tried to arrange the electrons in such a way. You can see, like, we knew that the electrons are revolving around the nucleus, but in this video I can see that they are, they're giving the electrons they're giving electrons a particular shape, the configuration of particular shape. What should I say about it? So you can see in here the first cell is containing only 2 electrons, and this is, you can written over here, one shell, and behind that, beneath that, 2 electrons, 2 or more shell, 8 electrons. So what are they trying to tell you over here? So they are just talking about the electronic configuration only. Okay, so do you remember in the Bohr model, in the Bohr's model, we just learned that nucleus is like just like in the middle, and the shells are just like that, isn't it? And when you move upward, the energy of the cells are getting increased. More you move move upward from the nucleus, the energy of the cell gets increased. Fine. Now you can place electrons in these shells. This was the thing, right? Stated by Bohr. Okay. Now, how many electrons can one shell occupy? So, from Bohr's model, you know that the first shell is called the K shell, the second shell is called the L shell, the third shell is called the M shell. Okay. But what is the capacity of each and every shell to hold the electrons over here? Okay. Now, there is a small rule given by Bohr, which was 2n square rule. According to Bohr, if n equals to 1, if n equals to 1, let's consider the situation like when k is there. So for k, n is equals to 1. N is the number of shell, okay, from the nucleus. So for k shell, the n is equals to 1. For L shell, the n is equals to 2. This is for the L shell. For when you are having n equals to 3, this is for M shell. Got my point? So if you just put this into this formula, you are going to understand how many electrons can be there in each cell. So when n equals to 1, at that moment, 2n square, this value would be 2. Okay. So from there only we can conclude that K shell has 2 electrons. So this is the maximum capacity of the K shell, which is it can hold 2 electrons. Okay, this is the maximum capacity of the K shell. Now, if you move on to the next part, when you are taking n equals to 2 for this thing, for L shell, it would give you the value. So this is giving you the value 2. So this would give you the value 8. This would give you the value 18. So this is the maximum capacity of the electrons, of the shells, that it can hold them, that number of electrons only. Okay. So it can hold only 2 electrons. It can hold 8 electrons, up to 8 electrons. This is the maximum capacity, and it can hold up to 18 electrons. Fine. So this is the capacity. Okay. Now, the thing is, you can see in this picture, there is another picture over here. You can see this is, they are talking about carbon only, right? So carbon has 6 protons and 6 neutrons, isn't it? The 6 proton system is carbon. How do I know? Because I have told you to remember the atomic number up to 20. You need to memorize this, okay? Even in the next class, we are going to discuss about the ions, the cations, the anions, and all these things. Even though if you, even then, if you don't remember the number of the atomic number up to 20, it would be, it would be very difficult for you to understand this. It's very simple. There are tons of mnemonic there in our, in the internet. Just go through it and you just try to remember these 20 uh, atoms. Okay, it's very simple. Okay, now if you just remember this, it would be very much easier for you. Chemistry would be very much easier for you. Okay, it would be better for your understanding. Now the thing is, from there I know that the atomic number 6 is for carbon. So atomic number is, this means the number of protons, right? We can also call it atomic number, isn't it atomic number. Tell me, if I ask you what is the number of electrons for this, so then you would definitely say, sir, the entire atom is neutral. The entire atom is neutral. So definitely number of protons is exactly equals to the number of electrons, isn't it? Because protons are positively charged particles and the electrons are negatively charged particles. From there, I think we can say that exact amount of proton and the electrons are just the same. So for that reason, we can say that the atomic number, from the atomic number, we get to know about the number of protons and the number of electrons, both of them. Fine, clear up to this? Now this was carbon. This structure over here, this was for carbon. Now you can see for carbon, there are 2 electrons in the first shell because this is the K shell, and K shell can hold up to 2 electrons only. But in the L shell, it can hold up to 2n square rule. So when n equals to 2, you can see in here. So L shell can contain 8 electrons. Okay, it is its maximum capacity. You can right now it is holding only 1, 2, 3, and 4 electrons. Fine. So let me show you the electronic configuration of carbon. So the electronic configuration of carbon. So how can we write this? Well, how to write the electronic configuration? So first what you have to do is you need to write the shells there in the atomic structure. You have read KLMNOP. This is how you need to write it. After that, write the name of carbon. Okay. Carbon has 6 protons, isn't it? So now 6 protons means 6p is equals to 6e. Okay, protons and electrons are just the same, right? The number. So you can see right like this 2 and 4. So this is going to be the electronic configuration, nothing more than that. 2 and 4, this is the electronic configuration of carbon. Okay, ignore the dogs shouting. Okay, ignore them, because I cannot control it. Okay, so yeah, right now you just have to ignore it. Okay, the focus on here. So the thing is, K shell has having 2 electrons over here, and the L shell is having 4 electrons over here, and this is the electronic configuration. The electronic configuration would be the electronic configuration would be, I'm not writing it. Okay, just write it. I'm not writing like this. Okay, say 2 comma 4. This is the electronic configuration. If we got it, so this is how you need to write it. Okay, just remember, whenever you got a number, just place it in K, L, M, and OP. Okay, just remember that each and every shell can contain, that what is the maximum number of electrons it can contain, right? So from there, I think you can figure out that what would be the electronic configuration. Fine, fine, fine up to this. Okay. Now, if you have got this, just tell me some of the questions. Let's see. Solve some of them. Uh, what is the electronic configuration of oxygen? You try it yourself. I'm not going to help you. What is the electron of configuration of oxygen coming? And what should I say? So oxygen was there. Oxygen is there, and magnesium as well. Electronic configuration of magnesium. Let's see. Okay, you just have to write like this. Okay, got it? So 2 comma 6 definitely for oxygen, right? And for magnesium it would be 2 8 2, isn't it? 2 8 2. This is the magnesium's electronic configuration because it is 12. Oxygen is 8, isn't it? So from there I think we can understand this is very important for us to remember the the atomic numbers. Okay, I just forgot the name of words. Okay, anyways, so atomic number, it's very important for you to remember, because on the basis of that only you are going to learn about the valency and the valence electron. So if I just go back to this picture over here, give me a moment. Yeah, so if I just go back to this picture over here, you can see the last shell. This is the last shell, right? So the last shell is called the valence shell, the valence electron as well. So the last shell's electron is also called the valence electrons. Okay, so this is another thing. So what does this word mean? Like, what do you mean by the word valence? Okay, what is valence and what is the valency and all these things? What it has to do with us? Okay, so let's see what is this. Now we would start with valency. Now, what is a valency? If I just consider that I have water, okay, if I just consider I have water, fine. Now, this water, in this water, the oxygen over here, it has a valency of 2. It has a valency of Straight for a moment, something's wrong. Here the valency of 2, right? It has a valency of 2. So for that reason, so from here I think we can understand the fact that valency is nothing but the number of hands, isn't it? So oxygen has 2 hands actually, so with which it is holding the hand of the hydrogen. So the valence is nothing but the number of hands. This is what valency is. Now, if I try to understand what is the target of valency, Valency's target, Valency's target is to make you stable. Is to make you stable. So whatever it takes to make yourself stable, valency would do that. If you want to take electrons, take it and be stable. If you want to lose electron, like lose it, and it can make it stable as well. So valency is a way through which you can understand if whether giving electrons or taking out electrons would make you happy. Okay, so this is what valency is. Got it? So now let's just understand what how it works. Okay, so the thing is, to understand about valency, I would just write a few lines. The only thing you need to remember about valency. Okay, so that is the number of electrons, the number of electrons donated, the number of electrons donated, let me see, yeah, or accepted during a chemical reaction. During a chemical reaction, the number of electrons donated or accepted during a chemical reaction is called valency. Got my point? So the number of electrons that is being donated or accepted to make yourself stable, to make the atom stable, that is called the valency. Let's just discuss about it for a moment. So the thing is, now how valency works. So before going to valency, we need to understand two things. It starts with, wait for a moment. Yeah. So we need to understand two things. One is duplicate rule. Wait for a moment. Yeah. So duplicate rule. This is the first one. And the second one is octet rule. Okay. These two rules are there. Duplicate rule and octet rule. Duplicate rule says that when K shell has 2 electrons, it is stable. Okay, this is what duplicate rule says. And octet rule says that when like after K shell, okay, when all the shells except K shell, when all the shells except K shell obtains they vary. All the shells except the K shell obtains 8 electrons. They are very stable. So from here, what are they trying to tell you? So they are trying to tell you there are two rules. Okay, two rules. One is the duplet rule, another one is the octet rule. When a shell is having 8 electrons, that is the most stable configuration of it. But apart from that, when you are talking about K shell, it cannot contain more than 2 electrons. So when it is fulfilled, it is the when the entire K shell, when it is fulfilled entirely, okay, so that would be when it has 2 electrons, right? So for K shell, so this is the primary idea. When the K shell has 2 electrons, that is called duplet rule. And apart from K shell, when the other cells have 8 electrons, we call it octet rule. It's up to you only. Okay, so this duplet and this octet rule. Okay, I think you got it completely. Okay, let me see. One still all the shells except K shell. Okay, okay, okay. So that was all about it. Okay. So now look into this question. Look into these things. Wait for a moment. This would work. Okay, let's see. When I have hydrogen, it has only one electron, right? Now, if it has one electron, if I am putting that electrons in the K shell LMN, they are not going to show you any values. For helium as well, you can see there are 2 electrons, but the thing is, it is already stable, isn't it? K shell is containing 2 electrons. Okay. So for that reason, what would happen? Helium would have no valency. Okay. Now, lithium. For lithium, what happened is, you can see the atomic number is 3. Okay. The number of electrons over here for lithium. Okay, what should be the formula of lithium? And this is not lithium or lithium plus. This is lithium. Okay, lithium is 3. So definitely it would be 3 only. Okay, if it is completely, if it is completely canceling each other, then it should be 3. Fine. Yeah. So the electronic configuration can be written as 2 1. Similarly, for beryllium, it is 4. Okay, so 4 would be 2 2. Similarly, it would be 2 3 4 5 6 7. So it goes on like that only. Okay, this is a continuous method, and it goes on like this. So from there, I think you can understand. From here, I think you have understood that this is how it looks like. Okay, in lithium, this is how it looks like for sorry, not in lithium. So for this compounds, the electronic configuration looks like this only. Okay, fine. So its valency would be 0 because it is having already like the K shell is fulfilled, right? What I mean to say is the K shell is fulfilled, right? So that is the thing. For that reason, what is happening? For that reason, I am going to take the K shell is fulfilled. So for that reason, they are not going to take any of the electrons from the outside. Got my point? So for that reason, the valence is 0. Now for lithium there is 2 1. So it would, what would happen? This 1 electrons would is willing to go out. If it goes out, then what would happen? Then this thing would be stable, very much stable. Okay. So for that reason, what would happen? Valency. Okay. So for that reason, what would happen? So you can see over here overall. So beryllium over here, it is having 4 electrons, so 2 2. Okay. And now it would take up these 2 electrons to make the K shell stable, the way that the lithium did. Okay, similarly it would give up 2 electrons. So thus lithium is also valence is 2. Okay, so in this way you can find out the valencies of each and everything, right? You'll be able to do that. Okay, so here you can take a small break. Yeah, it's only 26 minutes we are reading so far, right? So you can take a small break and we will just come back from here and we'll start from here only. Okay, so you just pause this video and take a short break. Okay, so welcome back. Then I think you have taken your break so far. Now I think we can start it again. So the thing is, you can see over here, like now coming back to the other elements over here. So it would be better if you just go through it on your own. Okay. In here, you can see I have written all of the atomic numbers, okay, and their valencies. Now you are the one who is going to do that, not me. Then how to find out the atomic number? I'm going to give you the atomic number and you have to find out the valency. So you can see there is one atomic number. Tell me what would be its valency. So I'm just helping you with this KLMN. Try to put this value like this. So over it would be like this, right? So K shell is having one electron. Okay. Now to fulfill it, you can do one thing. What can you do? You can give it one electron, right? Or you can take out one electron from here. You can do both the things, right? Both the things are equally probable. Whatever you do, you just need one electron to fulfill it. Okay, you just need one electron transport. So either it can be a donation of electron or it will be acceptance of electron. Whatever it is, only one electron is involved over here, right? So the number of electrons are involved, those are involved, that is going to be the valency. So from there I think we can say the valency is one because only one electron is involved over here. Let's just go to the next thing. So it is you can see valency of helium. So helium is having this configuration K2. Okay, now K shell is already completely filled up, so it is not like in need of anything else. So tell me what would be valency? It valency would be 0. Clear? Now lithium, it is 3, so 2 and 1. So if we just take out this electron, it would be stable, and that is what happening with him. For beryllium, you can see like the atomic number is 4. Okay, so it would be 2 2. It would be 2 2. So yeah, so 2 2. So the valency would be, it would take up these 2 electrons, and as a result the valency would be coming as 2. And I have made this I have written is 3 just to see whether you are just trying or not, right? If you are trying it, then definitely you would be able to find it out, some the discrepancy over here. So for valency, for the elements, those are valency 5, 2, 3, isn't it? So if it is 2, 3, we can say that the valency of this boron, what can it be? So it would just leave these 3 electrons, right? So for leaving this 3 electrons, you can see like the valency is 3. For carbon, okay, 4 electrons are leaving. Okay, so it can happen. It can leave, 4 electrons can leave or 4 electrons can come as well. So both of them are equal probable, and for that reason the valency of carbon is coming 4. Similarly, tell me what is the valency of nitrogen. So for nitrogen we can say this is 7, right? So just put it over here, KLM. Okay, so 7 2 5. Okay, the valency is so the atomic number is 7 2 5. So I can see there are 3 electronic gap over there. Okay, so sorry, yeah, so 3 electronic gap is there, because if you give this if you give this 3 electrons to this L shell, then what can happen? Then it would be N3 minus. Okay, so N3 minus would be KLM 28. Okay, so for that reason we this is, the valence of nitrogen would be 3. Okay, so this is how I think you can understand the rest of it as well. For oxygen it would be 2, so 8, so the valency would be 2. Okay, so this is how it works. Okay, so valence is the number of electrons you need to take in or you need to give up to be stable in your life. Okay, so that is called valency over here. Okay, so now let's just watch a video to understand about valency more. So are you having fun? Is it becoming easy for you? So valency part is very easy. Okay, you need to understand it properly. You'll be able to do each and every one of them. Okay, I've given you the list. You just go through the list and try to do it on your own. Try to solve it on your own. Then only you'd be able to understand. Okay, so try to solve it on your own. Don't just look into the notes and don't just try to read it from there. Fine. Now watch this video. To understand a few concepts related to atoms, let's begin with two simple elements. So they are starting with hydrogen and helium only. So you can see that they are saying helium is a quiet element and he does not react in, it does not react, okay? It does not react in chemical reactions, okay? So now they're asking us a question. Do you know why? Do you know why helium, argon, neon, krypton, xenon, radon? Okay, so I think all of them have something in similarities, something similar, right? So for that, the thing is, helium has the electronic configuration like this, right? For argon, the electronic configuration is like this. For krypton, the electronic configuration would be just like this. Okay, so this goes on like that only. Fine. So so yes, so that is the thing. So you can see the last shell is octet filled up. Here the duplet filled up. Here it is octet filled up. Okay, either it is octet or duplet filled up. Only then it would be very much stable. Fine. So now they are going to start the thing discussion about the valencies, but they are going to just revise the electronic configuration, all of it for within an hour. So that is the thing we have already discussed about it. The electronic arrangement is nothing but the layout or the array or the way of representing the electrons, right? So I think you can understand whatever they are trying to show us, right? They're trying to show us about the octet state, okay? And apart from that, some motivational speeches, okay, about the octet state. So how you can attain it, how you can, not the motivation. So what I mean is how to attain this octet, okay? The processes, what I mean to say is how to attain this octet or the duplet, okay? They are going to discuss about that only. Wasn't it a very good analogy, right? This is the same thing I just told you. Like they just try to grab as many chocolate as they can with his one hand. Okay, so that is the thing. Every atom wants to take how many electrons. The thing is to save to make a particular shell stable. Okay, you need to make it fulfilled. So every shell wants to be stable. For that reason, you need to make it fully filled. Okay, now. Okay, so I think you have got it so far. What they are trying to tell you, right? So let's see. Yeah, so here you can see the PPT of this chapter. Okay, so this is how they are going to tell you about the electronic configuration. This picture, I think we have discussed through this picture only. After that, the valency of the different types of element. I think you got it as well. Okay, so here is a very important thing over there. I'm going to show you how to understand. Okay, I'm going to show you how to understand the cricketing. What I mean to say is how to understand the balances. Okay, so if you have the number from there, I would show you how to understand the valency in a simpler way. Okay, later on. So that is the thing. Okay, now the thing is, yeah, let it be there. So that is the thing about the valency. So that how would you be able to know? So what you have to do is, let's just consider I have sodium. Okay, sodium is 11. Fine. Now if it's 11, then you can understand the electronic configuration will be 2 at 1. Okay, now what can be its valencies? Valency would be, if we just take out this one electron, it would be 1 only, right? So this is very simple to find out the valencies of a particular metal. But when you are talking about a group of metal, or when we are talking about like NaOH, okay, okay, when you have NaOH, you know the valency of Na, but you don't know the valency of OH, isn't it? You don't know the valency of OH. You know the valencies of each and of one atom at a time, but you not be able to know the valencies of the entire thing. Okay. Now I think you got the point how to calculate the valencies and all. Okay. Now we would just go through the video. This is the octet rule. Okay. This is a very good example. Okay, just go through it. So I think you got it so far. So what is the valency and or how these bonds are being, how they are getting generated. Fine. But yeah, still in the physical classes, you are going to learn about it in depth. Okay. Now, yeah. This was the entire thing about it. So I have tried to make it simpler for you. Okay. Now that's it about like in this video. I think you have got this all these points, and if I just go through the just wait for a moment. Yeah, if I just go through the FAQs, let me just see what was the FAQ in this chapter. The FAQ was uh, list of cations and anions FAQs. Okay, the outermost shell of the atom is known as so whatever it is. Right now you can see this is the outermost shell of the electron is already known as valence shell. Okay, so the option is 4. So this is very simple things. Okay, whatever it is very simple. And definitely you just keep on learning from Ask IITian, and definitely I will meet you in the next video. Okay, bye everyone, bye for your attention, and definitely we'll meet each other in the next class. Thank you everyone, bye.